So now very firstly we will go with this derivation, angle between radius vector and the tangent. So angle between radius vector and the tangent, the formula we have here it as tan phi is equals to r into d theta by dr. Sometimes this question they may ask you as, with usual notations, prove that tan phi is equals to r into d theta by dr. So let us begin with the proof. So the diagram of this particular case that we consider is that on xy plane, let us consider the random curve, that is the polar curve. Let this be the polar curve, r is equals to f of theta. So now for this particular curve, we need to find what is the angle between its radius vector as well as the tangent. So let me choose some random point. This be in the form P of r comma theta, because this is the polar curve that we are considering. So thus the ordinates will also be r and theta. So now at this particular point, let us draw the tangent. And from this particular point, from the origin is nothing but our radius vector. So here I am going to represent this as vector r. This is our tangent, and the angle theta is the angle made by radius vector and the initial line. And here this is nothing but our exterior angle. Let us denote that by psi. Now the angle between this radius vector and the tangent, see this line is our radius vector and this is the tangent. So this between these two is our angle between radius vector and the tangent. Let us denote that as phi. So this angle now we are supposed to prove, and that will be in terms of tan phi. So the abbreviations of this points and the curves and all, it is left based on the diagram. Now here straight away I'll start with, from the diagram we can able to see that the exterior angle we have, that is psi. This is our exterior angle, and from the concept of our geometry we know that this exterior angle, I am going to tick here, this exterior angle is equals to sum of the interior opposite angle, that is theta plus phi it is. So we have a standard statement that the exterior angle is equals to sum of the interior to opposite angles. So now on this particular, let us apply tan on both the sides. So you are supposed to apply tan on both sides. So we are going to get this as tan psi is equals to tan of theta plus phi. And this tan of theta plus phi, it is in the form of tan a plus, tan of a plus b. We can apply the formula as tan theta plus tan phi divided by 1 minus tan theta multiplied by tan phi. So this is the formula we have from our trigonometry, tan of a plus b formula. Okay. So let us denote this as equation number 1. Next, we have from the relation between polar and the Cartesian form. From the relation of polar and the Cartesian form, we have these equations. So here let me denote this as, let x comma y be the Cartesian ordinates. Let this be our Cartesian ordinates. At the same time, r comma theta is our polar ordinates. And from the relation between Cartesian and polar, we have the value of x. We have the value of x as r cos theta, and at the same time we have the value of y as r sin theta. So now let us differentiate this with respect to theta, both x and y. Differentiating both x and y with respect to theta, we get this as dx by d theta is equals to, see here we have x value as r into cos theta. R is also the function of theta. So we are supposed to apply the product rule here. So first function r multiplied by differentiation of cos, it is minus sine theta, plus second function cos, will keep it as it is, and differentiation of r, it is dr by d theta. Similarly, differentiating y with respect to theta, we get it as dy by d theta is equals to, here also y value we have it as r sine theta, both are in terms of theta. So therefore apply product rule. First function keep it as it is, differentiation of sine, it is cos theta, plus sine theta will keep it as it is, that is second function, and differentiation of r, it is dr by d theta, or you can simply just write it as r dash. Okay, so now here we are going to consider one of our previously known formula, that is slope of the tangent, that is tan psi is equals to dy by dx. So this dy by dx, we can apply the chain rule as dy by d theta divided by dx by d theta. By using chain rule concept, we can write this one. And now we have the value of dy by d theta and also dx by d theta. So that is dy by d theta, we have it as r cos theta plus r dash sine theta, that dr by d theta we can write it as r dash, whole divided by dx by d theta. Again here I'll write the positive term first, that is r dash, this dr by d theta. Okay, so next cos theta, will take it as it is, minus r into sine theta. So now for this we are supposed to divide this both numerator and denominator. We are supposed to divide numerator and denominator both by, we are supposed to divide this both numerator as well as denominator by r dash cos theta. Why we are dividing this is to match with our previous equation number 1. So this implies this tan psi on the LHS will be as it is. Okay. So on dividing this by r dash cos theta, we get it as, see the first term cos get cancelled. So we left with r divided by r dash plus r dash get cancels. Sine by cos is nothing but tan theta. So this whole divided by, again r dash divided by r dash cos theta divided by r dash cos theta gives 1 minus r divided by r dash sine by cos, it is tan theta. So let us note this as equation number 2. So now we have to compare our equation number 1. Please look at here, I am going to tick this one. This is our equation number 1 and this has to be compared with our equation number 2. So in place of sine theta, in place of tan theta, we have tan theta, and in place of tan phi, in our equation number 2, we have it as r divided by r dash. So I can give a line here as, on comparing equation number 1 with equation number 2, we get tan phi as r divided by r dash. So which can be rewritten as r multiplied by d theta by dr, because r dash is nothing but dr by d theta. So this can also be written in the another form, that is cot phi is equals to 1 by r into dr by d theta. So this is what we are generally use in the problems. So this is the required derivation of our angle between radius vector and the tangent.